Hey everyone! Now it's time to apply what we've seen in the previous lectures and write some code. But since it's the first time we'll be doing exercises together, I would like to walk you through the process. The best way to do the exercises is to check out the GitHub repository on your computer. You can find the link below this video. Then open the project with your favorite IDE, such as IntelliJ or VS Code. I'm personally using IntelliJ. And if you need some help setting it up on your laptop, you can find instructions in the introduction chapter of this course. And if you run into problems, please use the tooling channel on Slack to ask any questions. Now, for one reason or another, you might not be able to install the project on your computer. In case this happens, I've also configured an online editor as a fallback option. Again, you can find all the instructions in the introduction chapter. Okay, so now we're going to go through the questions one by one. First, I will briefly explain the objectives, and then I will give you some time to answer each question and write tests. Finally, I will propose a solution and discuss various refactoring options. Sound good? Okay, so let's open the file value function exercises, and we're going to work on the first exercise where we're going to implement select digits. Select digits is a function that takes an input string and it collects every single character that's a number. So things like 0, 1, 2, 3, 4, 5, and all the characters get discarded. For instance, if we call select digits on hello for world-80, we get back 480. But if we call select digits on welcome, it returns an empty string since the input text doesn't contain a number. So now please pause the video and try to implement select digits using the filter method from the string API. Okay, so let's do text.filter, and as you can see, filter expects a predicate function from character to boolean that determines which character are we going to keep. So how do we write this predicate function? We first need to define the input, so we can write c column char, meaning that this function takes only one input c and it's a character. Then we have an arrow, and then in the body of the function we need to return true if c is a digit. So we could write c equal 1 or c equal 2 and so on, but it's a bit of a pain. And it turns out that the character API has lots of convenience methods that lets us check whether a character is, for example, a letter, a white space, or a digit. So here we can say C is digit, and we're done. But can we make it more idiomatic? Yes, we can. The first thing we can do is to remove the type annotation around the input definition, because filter knows that it expects a function that takes a character. So we don't need to repeat ourselves. Then because this function has only one input, we can remove the parentheses around the input definition. Finally, if you have a bit of experience and you want to go one step further, you can use the placeholder syntax. It means that instead of naming the argument c and using it straight away, we can make the input anonymous and just say underscore, like that. In a sense, it's a way to consume the argument immediately without even giving it a name. This is the most concise and probably the most idiomatic syntax for simple functions like filter. However, there are some constraints with this syntax. We can only use the placeholder syntax here because we consume the input once. We wouldn't be able to use it if, for instance, we had to check if the character were a digit or a white space, because in that case we would need to use the input character twice. And there are other more subtle limitations too. For these reasons, I don't necessarily recommend using the placeholder syntax. It really depends on your experience and your style. Okay, so now that select digits is implemented, let's check that it works properly. I created a file called value function exercises test, this one. that is already set up with the scatest library, probably the most common testing library in Scala. And I've already written 2 tests for select digits. The first one is an example-based test, where I compare the results for the 2 examples we saw earlier, Hello for World-80 and Welcome. And the second test is property-based, where we generate a random input string and we verify that select digits always return a smaller result than the input, which makes sense since select digits remove characters. So let's run these 2 tests with this green arrow over there. All green. Now, before we move on to another exercise, I would like you to write a property-based test for select digits. You can copy-paste this one and change the name, so something like select digits, something. Then think about some properties that select digits must satisfy for all input. You will probably find it challenging if you haven't done it before, but it's a good exercise. Property-based tests cover a wide range of inputs without us having to care about corner cases. This makes also testing more fun, so I strongly encourage you to give it a try and practice this skill throughout the course. Now please pause the video and take a couple of minutes to think about another property for select digits. Here is one of mine. If select digits works, we know that all the characters in the output string must be numbers, right? So let's call select digits with a random input string. So let's do this, text. And let's verify that every single character that it returns is a number. So we need to iterate over strings. There are a couple of options. Here I suggest to use for each, another higher order function from the string API. So now we define the input, and now we need to write an assertion to verify that C is a digit. So we say assert C is digit. And we're done. Let's run the tests. All good. Now let's go back to the exercises and have a look at secret. Secret is again a function from string to string, but this time we want to convert all the characters to asterisks, which is similar to what happened when you type a password in a web browser. Please pause the video and try to implement secret, if possible using a higher order function from the string API. So we could try to generate a new string that has exactly the same size as text, but which only contain asterisks. However, it's common to get an off by 1 error with that kind of approach. Another option is to use map and transform each character into an asterisk. So let's do text.map, and as we can see, map takes an update function from character to character. So let's define the input, C, char, arrow, and now we need to convert the character into an asterisk. So let's just write this, and that's it. Now let's refactor this function a little bit. We have seen that we don't need to annotate the input type because we know that map takes a function that takes a character. Again, we only have one input, so we can remove the parentheses around C. Now, one thing we didn't have before is, you see here, C is grayed out. This is the IDE which tells us that C is not used in the body of the function. Good practice in this situation is not to name the input and use an underscore instead. So we can say this. This way we document to readers that this anonymous function takes an argument, but we ignore it. It's impossible to use it within the body of the function. Okay, so now let's verify that secret works. Let's open our test file. And let's write an example for secrets. Oh, by the way, this should have been select digits only returns number. And now let's write an example. So we're going to call secret. And let's do welcome123. And what we want to verify is that for every single character, we return an asterisk. So let's do this, just to verify that we get the same length. Should be good. And let's run the test. Perfect. Now we could write a couple more examples, but ultimately we'll never cover all the possibilities. So could you come up with at least one property-based test for secret? Please pause the video and have a go. So there are a few options. We could check if the input has the same length as the output, like we did in the lecture, or we could iterate over the output characters and check if they are all asterisks, as we did for select digits here. But here I want to show you a more generic property so that you can add it to your toolbox. Typical of functional programming, it has a fancy name. It's called idempotence. But it simply means that calling our function multiple times is the same as calling it once. And here it makes sense because once you call secret, all characters become asterisks. So if we call secret again, it's not going to change anything, right? So let's do this. Let's create a value once where we say secret on the random text. Then let's call create twice. That does the same thing, but except we call secret twice. And what we want to verify is that once is equal to twice. Let's run the test. All green. So idempotence is a really useful property because it means that we can safely retry a function. For example, when we make a REST request, it may time out for a number of reasons. Is it safe to retry it? Are we going to make 2 payments or submit 2 web forms? Well, if the request uses the verb put, it must be idempotent according to the specification. But if it was a POST request, we don't know. So it's really practical to have idempotent functions and to identify them as such in our codebase. Now let's go back to our exercises, and this time we're going to implement isValidUsername character. So isValidUsername character is a function that takes a character and tells us if it can be used in a username. The requirements are as follows. It can be a lowercase or uppercase letters, a digit, or a special character like dash or underscore. So I'll let you pause the video and try to implement it yourself. So let's have a look at the character API. So if we do char dot, we can see lots of convenience methods that start with is something. So for example, we have isLetter, isDigit, and we even have isLetter or digit. That's perfect. It caters for first 2 requirements over there. Now we still need to test that our character can be a dash or an underscore, and for this I propose to do it manually. So we can say char equal dash, char equal dash, or char equal underscore. That's it. Next, we're going to work on isValidUsername. This function takes a string representing a username, and we want to verify that every single character in that string is valid according to the requirements from the previous function. So for example, John-Doe is valid because it only contains letter and a dash. But asterisk John asterisk is invalid because asterisk is not approved. So please pause the video and try it out. Just one thing to consider is try to search the string API to see if there is any useful method for that scenario. So we know we want to call isValidUsername character on every single element of username because we don't want to repeat ourselves. So let's check the string API if there is any method that takes as an input a function from character to boolean. So what do we have? Nothing. Still nothing. So here we have for all and filter. So it's probably not going to be filter because we don't want to remove characters from the username. So let's have a look at for all. What does the documentation say? Test whether a predicate holds for all the characters of this string. That sounds exactly like what we want. So let's do for all. We define the input, and then we call our isValidUsername character function with it. It seems to work, but it's a bit annoying to define an input just to consume it straight away. So as we've seen before, we don't have to name the argument in that scenario. We can just say underscore here. Another thing we could do is, if we look at the definition of for all, it takes a val function from character to boolean. But isValidUsername character is a def function from character to boolean. So it's not exactly what we want, but it's pretty close, right? And as you might remember from the val versus def lecture, there is a syntax in Scala that lets us convert a def function into a val function. It's called eta expansion. And as it's often the case in Scala, it relies on an underscore, but this time after the method's name. So now this time we do an eta expansion, transforming this def function into a val function. Finally, you might remember another point in that lecture when I said that when the compiler expects a val function, it can automatically do the conversion from def to val. And we are in this situation here. So actually we can remove this underscore and it just works. So there is a lot going on in this simple line. And I think it was worth spending the time on it together because we've learned a lot from it. Now, how do we test isValidUsername? We could come up with a couple of test examples, and that would be fine. But finding a good property for this function isn't so straightforward. At least not one property where we don't duplicate the implementation. So please pause the video and try to think about it. So in a situation like this, I often find a good strategy is to generate a random input and transform it slightly before calling the function we want to test. Then I think about the impact this transformation has on the result. So for example, here we generate a random username, and what happens if we reverse it? So if we say isValidUsername username.reverse, will it be true? Will it be false? Well, it depends on the original username. If this username was valid, then reversing it will still make it valid, and false otherwise. In other words, reversing a username doesn't affect its validity. So we should be able to say isValidUsername username. Let's run the test. All good. Other potential transformation we could have tried could have been like uppercasing or lowercasing the username, or maybe truncating it. So please comment on this video or in Slack and let me know your ideas on how to test this function. Okay, so let's go back to the exercises again. Now we're going to implement a couple of methods for a case class point. It's a class that has three fields, x, y, and z, which represent a point in a 3D system. Now we're going to implement isPositive, a method of point that verifies that x, y, and z are all positive numbers. So for example, for point 249, it should return true, but for point 0, -2, 1, it should return false. So I'll let you pause the video to both implement and test it yourself. Just one thing to keep in mind is that isPositive is a method of point, meaning that within the body of isPositive, we have access to x, y, and z. So the implementation is quite straightforward. We can say x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. As usual, we can write a couple of test examples, but the interesting part is the property-based testing. What we can do here is to generate 3 random positive numbers and verify that isPositive returns true. How do we generate random positive numbers? Well, what we can do is to generate random numbers and use the abs method to make them positive. So let's do this. For all x int, y int, z int, and put them all together in a point, x, y, and z. And we transform x by saying x.abs, which stands for absolute value, y.abs, z.abs. And when we call is positive, we expect it to be true, right? So let's run the test. It's interesting. So it failed, and the testing library tells us exactly which input broke the test. So it seems that when one of the numbers is minus 2 billion something, the test fails. You may not know this, but this specific number is the minimum value for an int on the JVM. And it turns out that the issue here is with abs. When you call abs on int min value, you get back a negative number, which is incorrect in mathematics, but it is a behavior in both Scala and Java. So this is kind of a side benefit of property-based testing. It lets us discover all sorts of edge cases we never realized existed. And it also gives us an endless supply of anecdotes to discuss with our colleagues. So how do we change this test? Well, instead of using abs, what we could do is max 0. This way, if the number is negative, it will be replaced by 0. Let's run the test again. And this time it passed. So there are actually better ways to customize a random generator, but that's something I'm planning to show you in another video. So now, let's go back to the exercises, and we're going to implement isEven, which verifies that x, y, and z are all even numbers. I'll let you pause the video and implement it. So one way to check if a number is even is to look at the result of its modulo 2. For example, 8 modulo 2 is equal to 0, but 7 modulo 2 is equal to 1. So here we can say x modulo 2 equals 0 and y modulo 2 equals 0 and z modulo 2 equals 0. So not very elegant, but it should work, and I'll let you verify it. So now both isPositive and isEven are really similar. They both check that one property, positive or even, is valid for x, y, and z. So now what we're going to do is to write a higher order function called forAll that tries to capture this pattern. ForAll takes a predicate function from int to boolean, and we want to check if this predicate is valid for all fields of point, exactly like the forAll we use for string. For example, forAll underscore equal 1 will return true for point 111 because x, y, and z are all equal to 1, but it will return false for any other point, right? So please pause the video and try to implement and test it. So the implementation is quite simple. We want to call predicate on x and predicate on y and predicate on z. And how do we combine these three boolean? We use AND because we want all of them to be true. That's it. Now, to test forAll, I suggest using the oracle technique. It's a very common property-based approach that we can use when we have a reliable source for comparison. For example, if we were to implement a new sorting algorithm, we could compare its result with the sorting method from the standard library, which we assume is correct. Here what we can do is to generate 3 random numbers and a random predicate function from int to boolean. Then we're going to wrap these 3 numbers in a point, as we did before, and we're going to call for all form point with this predicate function. So what are we going to use for comparison? What we can do is actually put these three numbers in a list. So we can say x, y, and z in a list, and use the for all method from list, since it's a standard method on collections. Let's run the test. Nice, isn't it? So now let's go back to our exercises one last time. And what we're going to do is to try to refactor is positive and is even using for all now that we have it. So I'll let you pause the video and try it out. So is positive can be refactored using for all underscore greater than or equal to 0, and is even using for all underscore modulo 2 equal 0. Right, so it's a bit of a toy example, but I would still argue that it's a good refactoring. First of all, we reduce code duplication. Now both is even and is positive are implemented in terms of one method, for all. But also, and I would say most importantly, we made our intentions clear. When someone reviews our code, they will clearly see that we created a single predicate function and that we dispatch it to x, y, and z. Well, before, it wasn't necessarily obvious that the same function was applied to all fields of point. So I hope you guys enjoyed these coding sessions as much as I did. Please don't hesitate to share your solutions and your tests on Slack or by commenting on this video. See you soon.